Okay, let's get into it. Number 10. The Oh My God particle. On the night of October 15th, 1991, a detector sitting out in the Utah desert recorded something that, by rights, should not have been possible. A single particle. One, smaller than an atom. And it came down through the sky carrying the kind of energy you'd normally associate with a physical object you could hold in your hand. Here's the comparison the physicists themselves reach for. Imagine a baseball thrown by a major league pitcher, somewhere around 60 miles an hour. Now take all of that energy, the whole windup, the whole crack of it hitting the glove, and pack it into one subatomic particle. That's what hit the atmosphere that night. A speck so small it makes a dust mote look like a continent, hitting with the punch of a thrown ball. The detector that caught it was called the Fly's Eye, out at Dugway Proving Ground. And when the physicists worked out the number, the energy came to around 3 times 10 to the 20th electron volts. You don't need to know what an electron volt is. You just need to know that it's millions of times more energy than we can give a particle inside the Large Hadron Collider, the most powerful machine our entire species has ever built to smash particles together. Nature did it without trying. Out there, somewhere, casually. The thing was moving at very nearly the speed of light. And I mean nearly in a way that's hard to even hold in your head. If you put this particle in a race with a beam of light, and you let that race run for a full year, light would win. But only by about the width of a fraction of a hair. That's the gap. A year of running, and the particle falls behind by almost nothing. One of the physicists who looked at the data just said, out loud, "Oh my God." And the name stuck. That's the actual name. The Oh My God particle. Now scientists will tell you, correctly, that ultra-high energy cosmic rays are real. That they exist. That this one was measured properly, and it isn't some glitch. All true. But here's the thing. There's a rule in physics, a sort of cosmic speed bump, that says a particle this energetic shouldn't be able to travel very far across the universe without getting worn down by bumping into the leftover light of the Big Bang. Which means whatever flung this thing at us had to be, in cosmic terms, somewhere in our neighborhood. And to this day, after more than 30 years of looking, we have never found the source. We don't know what it was. We just know it threw something at us once, very hard, and then went quiet. Somewhere out there is an engine we can't see, capable of throwing a baseball's worth of fury into a single grain of nothing. And it's still running. Number 9. The planet where it rains glass. 63 light years from here, which in cosmic terms is basically next door, there's a planet called HD 189733b, and if you saw it from a distance, you'd probably gasp at how beautiful it is. It's blue, a deep, rich cobalt blue, the same blue you see when you look at a photograph of Earth from space. So your brain does the obvious thing. Blue planet, water, oceans. Maybe somewhere you could stand on a shore and watch the waves. And you would be so wrong, it's almost funny. That blue doesn't come from water. There isn't a drop of it. The blue comes from the atmosphere itself, which is full of tiny particles of silicate. And silicate is, essentially, the stuff we make glass out of. Up in those howling clouds, the silicate condenses. It forms little solid shards. And then it falls. It rains. It rains glass. And it doesn't fall gently, straight down, the way rain falls here. On this world, the winds blow at up to 5,400 miles an hour. That's about 7 times the speed of sound. So the glass doesn't drop. It flies, sideways. A horizontal storm of molten and hardening glass screaming around the planet at supersonic speed in an atmosphere hot enough, around 1,700 degrees Fahrenheit, to glow. Anything caught in it wouldn't be rained on. It would be sandblasted out of existence in a heartbeat. Astronomers actually pinned down that blue color using the Hubble telescope back in 2013, by watching how the light dimmed as the planet slid behind its star. It was the first time we'd ever really nailed down the true color of a world around another sun. And the answer was gorgeous and lethal. Here's the part that stays with me. The exact same thing that makes that planet beautiful, that soft, oceanic, Earth-like blue, is the thing that would kill you. The silicate haze is the paint and the knife at the same time. From far enough away, it looks like home. Get close, and it's a meat grinder made of weather. Space does this a lot, actually. It dresses the most hostile things it has in the prettiest colors it can find. And sometimes that blue you're looking at isn't an ocean. It's a warning you just can't read yet. Number 8. The Pinwheel Star. About 8,000 light-years away, in the direction of the constellation Sagittarius, there's a thing that looks, in the telescope, almost too perfect to be real. It's a spiral. A glowing pinwheel of dust, curling outward in a smooth, geometric coil, like someone drew it with a compass. It's called WR104. And for about 20 years, a lot of very serious astronomers have looked at that beautiful spiral and felt a little bit sick. Let me explain why. At the center of that pinwheel are two stars locked in orbit around each other, going around roughly every 8 months. One of them is a Wolf-Rayet star. And a Wolf-Rayet star is a massive star in the final, furious chapter of its life, shedding its outer layers, burning through what's left of itself. The two stars' winds slam together and spin out that gorgeous spiral of dust as they orbit. It's like cosmic cotton candy being spun by two dying suns. The problem is what happens when a star like that finally goes. When a Wolf-Rayet star collapses and explodes, it can, under the right conditions, produce something called a gamma-ray burst. And a gamma-ray burst is not a gentle thing. It's the single most violent kind of explosion we know about in the universe. It doesn't spray its energy in all directions. It fires it in two tight beams, out of the star's poles, like a lighthouse, like a barrel. And here's what made people's blood run cold. When we first studied WR104, the way that perfect spiral was oriented suggested we were looking at it almost straight down its axis, down the barrel, which raised a question nobody really wanted to ask out loud. Is that thing pointed at us? For 2 decades, that was the open, unsettling answer. Maybe. We weren't sure. There was this loaded gun 8,000 light-years away, and we couldn't quite tell which way it was facing. Now, the good news. In 2025, astronomers using the Keck Observatory in Hawaii took a much closer look, and they found that the orbit of those two stars is actually tilted something like 30 or 40 degrees away from us. Not down the barrel, after all. Off to the side, we can apparently breathe out. But here's the thing. That same study, the one that calmed everyone down, also found that the system was stranger than our old model said. The geometry didn't match what we thought we knew. So yes, the gun is probably pointed away from us. But the lesson sitting underneath that relief is a little colder. For 20 years, we were confidently wrong about what we were looking at. We thought we understood the gun. We didn't. And it makes you wonder how many other quiet, beautiful spirals are out there that we haven't looked at closely yet. Number 7. The Boötes Void. In 1981, an astronomer named Robert Kirshner and his colleagues were doing something that sounds boring and turned out to be terrifying. They were mapping galaxies, measuring how far away they are, plotting them out, building a three-dimensional picture of where the stuff in the universe actually sits. And in one particular direction, toward the constellation Boötes, they found a hole, not a small hole. The Boötes Void is a roughly spherical region of space, about 330 million light-years across. And inside it, there is almost nothing. Let me try to make that number mean something, because 330 million light-years is not a thing your brain can picture. In a normal chunk of the universe that size, you'd expect to find something like 2,000 galaxies. 2,000 glittering islands of hundreds of billions of stars each. Inside the Boötes Void, we've found around 60. 60, where there should be 2,000. It's not completely empty. It's just empty enough to be horrifying. And here's the line that gets passed around about it, the one that genuinely keeps people up at night. If our galaxy, the Milky Way, happened to sit at the center of the Boötes Void, if we'd been born in the middle of all that nothing, then for most of human history, we would have looked up and seen our own stars. And beyond them, just darkness. The nearest other galaxies would have been so far away that we might not have discovered they existed until something like the 1960s. We would have spent thousands of years absolutely certain that our galaxy was the entire universe. That this was all there was. That we were, completely and finally, alone. We weren't born there. We got lucky. We were born in a busy neighborhood with galaxies all around us to find. But somewhere out there are galaxies that did draw that short straw. Worlds, maybe, sitting in the middle of the void, where any astronomers looking up would have every reason to believe the lights they can see are the only lights that have ever been. Now, scientists are quick to say there's nothing exotic going on here. Big voids are exactly what you'd expect from the way the early universe clumped up. Matter pulled together in some places and drained out of others, like the universe is a vast, slowly drying sponge. The void isn't a mystery. It's just very, very big and very, very empty. But knowing the explanation doesn't make it smaller. There is a room in the universe with the lights off, and there are things living in it that may never know the rest of the house is here. Number 6. Tabby's star. In 2015, an astronomer named Tabitha Boyajian was going through data from the Kepler Space Telescope, which had spent years just staring at one patch of sky, watching the brightness of thousands of stars, looking for the tiny dips that happen when a planet passes in front of one. And she found a star that was doing something nobody had ever seen before. Most stars, when a planet crosses them, dim by a tiny, neat, predictable amount, a fraction of a percent, and then they brighten back up on a perfect schedule like clockwork. This star, officially KIC 8462852, but everybody just calls it Tabby's star after her, was not doing that. It was dimming in huge, ragged, chaotic gulps, sometimes by 2 or 3%, and on some occasions by as much as 22%, almost a quarter of the star's light, just gone, in a pattern with no rhythm to it at all. Think about what that takes. To block 22% of a star, you need something enormous sitting in front of it. A planet wouldn't do it. Even a big planet only blocks a sliver. This was something else. Something huge and irregular. And frankly, nobody had a clean answer. So somebody said the quiet part out loud. What if it's not natural? What if something is being built around that star? There's an old idea in science, a megastructure, sometimes called a Dyson swarm, where a sufficiently advanced civilization, hungry for energy, builds a vast fleet of panels and collectors around their own sun to catch its light. And if you were watching a half-finished one of those from 60-odd light years away, this messy, irregular dimming is more or less exactly what you might expect to see. For a little while, that possibility was genuinely on the table, not as a joke, as one of the live options that serious astronomers were actively discussing. The most mysterious star in the galaxy, and maybe, someone was home. Then the careful work came in, and it pointed somewhere quieter. When astronomers looked closely, they found the star dimmed more in ultraviolet light than in infrared. And that detail matters, because a solid object, a panel, a structure, a planet, would block every color of light equally. Only something made of very fine dust dims some colors more than others. So, The verdict landed. Not a megastructure. Just dust. Probably the shattered remains of comets, or some unlucky moon, drifting in uneven clouds. Dust. Okay. But here's the thing that I can't quite let go of. The dust explanation covers the dimming. It does not fully, cleanly, comfortably explain just how deep and how weird and how irregular those dips were. There's still a little bit of fraying at the edge of that answer. The case is closed, technically. It's just not closed in a way that lets you stop thinking about it. And for one strange year, the smartest people we have genuinely could not rule out that we'd caught a civilization in the middle of building something around its star. Number 5. The storm that missed us. On July 23rd, 2012, the sun did something that, if it had happened 9 days earlier, you would absolutely remember. Because there's a decent chance you'd have spent a chunk of the last decade living without reliable electricity. What happened is the sun launched a coronal mass ejection. That's a name for when our star peels off a colossal blob of its own magnetized plasma and hurls it out into space at millions of miles an hour. They happen fairly often, and most of the time they miss us, or they're small enough that they just give us pretty auroras. This one was different. This one was what scientists call a Carrington-class event, named after the granddaddy of all solar storms, back in 1859, which was so powerful it set telegraph offices on fire and made the wires spark. The 2012 storm was in that league. Maybe worse. If it had hit Earth squarely, the estimates of the damage are genuinely hard to read without wincing. We're talking about a geomagnetic storm strong enough to fry transformers in power grids around the world. The kind of damage that doesn't get fixed in an afternoon, because the big transformers that run civilization take months or years to build and replace. One study put the potential economic cost to the United States alone somewhere between $600 billion and $2.5 trillion. Not the global cost. Just one country, and it crossed Earth's orbit. The blast went right through the path our planet travels on. The only reason you've maybe never heard about it is timing. Earth had been sitting in that exact spot in space about 9 days before the storm came barreling through. 9 days. We move on, the spot empties out, and the storm sailed through the place we'd just been like a truck running a red light a few seconds after you'd already crossed the street. And here's the detail that turns this from a near miss into something stranger. The reason we know so much about how bad it would have been, the reason we can put numbers on it at all, is that the storm didn't just sail off harmlessly into nothing. Out of all the empty space it could have crossed, it happened to slam directly into a spacecraft called Stereo A, which was one of the very few machines we had built specifically to measure exactly this kind of event. It took the full hit and recorded everything. So sit with that for a second. The disaster missed us by 9 days. And the only reason we even understand the disaster we dodged is that it randomly struck the one instrument in the solar system equipped to take notes. If it had missed that too, we'd have never known how close we came. We'd be walking around right now, completely unaware that the sun had taken a swing at us and barely whiffed. The sun is not angry at us. It doesn't aim. But it's a 100 million mile wide nuclear furnace having weather, and every so often the weather comes straight for the spot where we live. Most of the time, we're not standing there. July of 2012, we just stepped away. Number 4. Oumuamua. In October of 2017, a telescope in Hawaii called Pan-STARRS caught something moving through our solar system that had never been seen before. Not a comet from our own backyard. Not an asteroid that's been orbiting our sun since the beginning. This thing was a visitor. It came in from interstellar space, from somewhere else entirely, swung around our sun, and was already on its way back out. The first confirmed object from another star system that we had ever laid eyes on. They named it Oumuamua, a Hawaiian word that roughly means a scout or a messenger from far away. And almost immediately, it started behaving strangely. The first strange thing was its shape. As it tumbled, the amount of sunlight bouncing off it swung wildly, getting about 10 times brighter, then dimmer, then brighter again, every 8 hours or so. The only way to get a brightness swing that extreme is if the object is wildly, almost cartoonishly elongated, like a cigar, or, by some readings of the data, like a flat disk. Either way, nothing like the lumpy potato-shaped rocks we're used to. It was a sliver, tumbling end over end through the dark. But the shape wasn't the part that really got people arguing. The part that got people arguing was that Oumuamua sped up. As it swung away from the sun, astronomers tracked its path carefully, and they found it was accelerating, getting an extra little push outward that gravity alone could not account for. The measurement was rock solid, confirmed to an extraordinary level of confidence. Something was giving this object a shove. Now, for a comet, that's not weird at all. Comets get pushed around all the time, because as they near the sun, they heat up. They spew out gas and dust, and that jet of material acts like a little engine, nudging them along. So, easy. Oumuamua is a comet. Case closed. Except, and here's the whole thing. When a comet does that, you see it. You see the gas. You see the dust. You see the tail. It's the most photographed thing comets do. And Oumuamua had no visible tail. No coma. No cloud of gas around it. Nothing. It had the push that outgassing creates, but none of the outgassing you should be able to see creating it. The engine was running, and the exhaust was invisible. So we had a thin, tumbling sliver of something from another star, accelerating under a force with no obvious source. And a Harvard astronomer named Avi Loeb looked at all of that and said something that made a lot of his colleagues deeply uncomfortable. We should not, he argued, completely rule out the possibility that this thing was made, built. A piece of technology, maybe a light sail, a thin sheet pushed gently by sunlight, drifting between the stars. The Breakthrough Listen project even pointed a giant radio telescope at it to listen for any kind of transmission. They heard nothing. To be fair to the rest of the field, and they'd want me to be, most astronomers think there's a natural answer. A fragment of a strange kind of frozen world, made of nitrogen ice or hydrogen ice that outgasses in a way too faint for us to have spotted. That's probably what it was. Probably, but it's gone now. Oumuamua is already out past the planets, tumbling back into the dark it came from, and it is never coming back. We got one look. A few weeks of data on the first thing we ever saw arrive from another star, and we will spend the rest of human history not quite sure what it was. Number 3. The Great Attractor. Here's something nobody really tells you, and once you know it, it's hard to unknow. Right now, as you sit there feeling perfectly still, you are moving. The Earth is spinning. The Earth is going around the sun. The sun is going around the center of the Milky Way. All of that you might have heard before. But there's one more layer. The entire Milky Way galaxy, the whole thing, all of its hundreds of billions of stars, with us tucked inside one of its arms, is falling. We are being pulled, right now, toward a single point in space. And so are tens of thousands of other galaxies. We're moving toward it at around 600 kilometers every second. That's something like 1.3 million miles an hour. Our whole galaxy, streaming through the universe at over 1 million miles an hour toward one spot. And that spot has a name. We call it the Great Attractor. So naturally, you want to know, what is it? What's down there, pulling our entire galaxy and thousands of others toward it like water circling a drain? And here's the genuinely unsettling answer. We don't really know, because we can't see it. The Great Attractor sits in a direction that, from our point of view, is blocked. It lies behind the main body of our own Milky Way, behind the thick, glowing band of stars and dust that you see arching across a really dark night sky. From inside our galaxy, looking out toward the Great Attractor means trying to look through the brightest, densest, dustiest part of our own home. Astronomers actually have a name for that blocked-off region of the sky. They call it the zone of avoidance, the part of the universe we cannot look at, because our own galaxy is in the way. So we are being pulled at over 1,000,000 miles an hour toward something we are physically unable to look directly at. We can feel the tug. We can measure exactly how fast we're being dragged. We just can't see the hand that's doing the dragging. Now, the calmer scientific take is that the Great Attractor isn't a monster or a thing. It's a place, a massive concentration of galaxies and dark matter, the gravitational center of a vast structure called Laniakea, a supercluster that contains our galaxy and around 100,000 others. It's gravity, doing what gravity does, on a scale that's almost impossible to feel the size of. But even that comes with a twist that makes it worse, not better. Because the Great Attractor itself isn't even the final destination. When astronomers map the larger flow, it looks like the Great Attractor, and everything streaming toward it, us included, is itself being pulled toward something even bigger and farther away. A pull, behind a pull, behind a pull. We are falling toward a thing we can't see, which is falling toward a thing we can barely detect. And nobody can tell you where the bottom of that staircase is, or if there even is one. You are not standing still. You never have been. You are being carried, your whole life, toward a horizon you're not allowed to look at. Number 2, the WOW signal. On the 15th of August, 1977, a radio telescope in Ohio called Big Ear was doing what it did every night, quietly listening, sweeping across the sky, recording the faint hiss and crackle of the universe onto long strips of computer paper, which a human being would go through later, by hand. Nobody was sitting there listening live. The sky was talking to a printer in an empty room. A few days later, an astronomer named Jerry Amon sat down with the printout from that night, running his eyes down columns of numbers that mostly described background noise, low values, quiet sky, and then he hit a sequence that stopped him cold. The signal had come roaring up out of the noise, strong, clean, and sharp, held for about 72 seconds, and then faded back down. On the paper, it read 6EQUJ5, a little code for how the intensity climbed and fell. And Amon, looking at the strongest, cleanest signal that telescope had ever caught from deep space, picked up a red pen, circled it, and wrote one word in the margin. Wow, that's it. That's the name. The WOW signal. Named after a man's honest, involuntary reaction to seeing it. And the more you learn about that 72-second burst, the stranger it gets. For one thing, it was narrowband, meaning it was concentrated into a very tight, very specific range of frequencies. Nature doesn't usually do that. Natural sources of radio waves, stars and gas clouds and the like, tend to smear their signal out across a broad range. A tight, narrow signal on one precise frequency is the kind of thing you make on purpose, the kind of thing a transmitter makes. And then there's the frequency it landed on. The WOW signal came in right around 1,420 megahertz. That number is special. It's the natural frequency of hydrogen, the most common element in the universe. And because it's a frequency that any civilization anywhere in the cosmos would know and recognize, scientists had argued years earlier that it would be the logical channel to broadcast on if you wanted to be heard. We had, in effect, guessed which station an alien signal would come in on. And then a signal came in, almost exactly on that station, from the direction of the constellation Sagittarius, near the heart of our galaxy. So, of course, the very next night, and for years and years afterward, astronomers pointed telescopes back at that same patch of sky, and they listened, and they waited. Nothing. Ever. Not once. Jerry Emmon himself went back and listened. Other telescopes, bigger and more sensitive, swept that spot again and again across the decades. In nearly 50 years, the sky has never said it twice. And that's the part that haunts me about this one. It's not the mystery of what it was. It's the silence afterward. Because whatever it was, even if it was something perfectly natural that we just haven't pinned down, for 72 seconds, on the exact frequency we'd have chosen, from the middle of the galaxy, something reached our little telescope in Ohio. And then it was gone, and it has never, ever come back. One word, in red pen, in the margin of a piece of paper. The single most tantalizing thing we have ever almost heard. And we don't even get to know if anyone was on the other end. Number 1, vacuum decay. Everything we've talked about so far is something out there. A particle, a planet, a storm, a void, a signal, something at a distance that you can point a telescope at. This last one is different. This last one isn't about a place in the universe. It's about the universe itself, and a quiet possibility sitting underneath everything that may be the most unsettling idea in all of physics. Here's the setup. When physicists talk about empty space, true, total vacuum, the nothing between the stars, they've come to suspect that it might not actually be as empty, or as final, as it looks. Empty space has energy in it, a kind of baseline level. And the deeply uncomfortable question is whether the level our universe is sitting at is really the bottom, the true, lowest, most stable resting state, or whether it's just a ledge, a place that looks stable, that's held steady for nearly 14 billion years. But that isn't actually the bottom of the valley. Physicists call that a false vacuum, a universe resting on a ledge when there's a deeper floor somewhere below. And in 2012, when we finally discovered the Higgs boson and measured its mass, the numbers we got back placed our universe, by a lot of careful calculations, right around the edge. Not clearly stable, not clearly doomed. Right on the knife's edge between the two. Metastable is the word. Probably fine. Probably. For now. So here's what vacuum decay actually is. If our universe is sitting on that ledge, then somewhere, someday, through the strange dice roll rules of quantum mechanics, a tiny bubble of the true, lower energy vacuum could simply pop into existence. A little pocket of the way things are really supposed to be. And because that bubble would be at a lower energy than everything around it, it wouldn't just sit there. It would grow. It would expand outward in every direction, a wall of true vacuum eating the false vacuum it came from. And it would expand at nearly the speed of light. Inside that bubble, the laws of physics would be different. Not slightly different. Fundamentally. The strengths of the forces, the masses of particles, the rules that let atoms hold together, and chemistry happen, and matter exist. All of it could be rewritten the instant the wall passed through. Everything the bubble touches simply stops being able to be what it is. Stars, planets, people, the works. Not destroyed in any way you'd recognize as an explosion. Just edited out. Replaced by a region of space running on different rules. Rules that almost certainly have no room in them for anything like us. And now, here's the thing about this one. The thing that makes it different from every fear on this list. That wall is moving at the speed of light, which means it arrives at exactly the same instant as the light that would show it coming. There is no warning. There can't be. You cannot see it approaching, because seeing requires light, and the light and the wall arrive together. If a bubble like that is expanding toward us right now, and it could already be out there, could have started 1 billion years ago, halfway across the universe, we would have no hint, no flash, no sign in the sky. One moment, everything would be exactly as it is, and the next, there would be no moment, and no you to notice it had stopped. Now please hear the scientists clearly on this, because they're right, and it matters. This is deeply theoretical. The best estimates say that even if our vacuum is sitting on a ledge, the time it would take to decay is staggeringly, almost incomprehensibly longer than the current age of the universe. You are not in danger tonight. Your children are not in danger. By any reasonable measure, this is a thing to find fascinating, not a thing to lose sleep over. But step back from the odds for a second and look at the shape of the idea, because the shape is the point. We have spent this whole journey looking outward, at violent particles and beautiful lethal planets and the silence after a signal, and feeling, underneath it all, that we are small observers watching a vast and dangerous universe from a safe little distance. Vacuum decay quietly removes the distance. It says the floor you're standing on, the very rules that make you possible, might itself be temporary. That existence isn't a fixed stage on which scary things happen. It might be one more thing that's true for now. And maybe that's the real discovery hiding behind all 10 of these. Not that the universe is full of frightening things, but that the universe never promised to stay the way it is. We are brief, lucky patterns, holding together for a little while, in a cosmos that does not owe us its rules. The most disturbing thing out there was never a particle, or a planet, or a star aimed our way. It's that all of it, including us, is borrowing its existence, one quiet moment at a time. And the only sane thing to do with a moment like that is to actually notice you're in it. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them. See you in the next one.